Okay, today's lesson is lesson 6.1 out of the Decimals and Fractions book. If you are in Mrs. Walker's class, we'll be starting on page 50. And lesson 6.1 is area with fractions. This will be a 2-page notes today. A lot we have to cover in this lesson. Let's review. Whenever we're dealing with measurements, and it says we're going to be dealing in fractions, that means we're working with the customary units of measure, which for us means inches, feet, yards, miles, okay, not the metric system. Okay, if we were dealing in metric numbers, millimeters, centimeters, meters, kilometers, okay, that would be finding area with decimals, right? So fractions stick with inches and decimals stick with centimeters and their so-ons. All right, so the warm-up for lesson 6.1 has 4 problems. So warm-up, and problem number 1 is 4 1/8 times 2 1/3. Problem number 2 is 3 1/4 times 1 5/6. Problem number 3, 1/2 times 3/4. Problem number 4, 1/2 times 2/5 times 10/22. Okay, those are your 2. Now, if you're having any problems remembering how to multiply mixed numbers or fractions to fractions, then you need to go back and look at lessons 5.2 and the later one for mixed numbers. I can't remember it off the top of my head. But block 5, you need to go back and look at those if you're having any trouble with these. All right, our I can statement for this lesson is I can find area with fractions or mixed numbers. With fractions or mixed numbers. I think I was about to write mixed twice. All right, I can find area with fractions or mixed numbers. Okay, that's our I can statement. So with my dark green pencil, I like to draw a line here. That's the end of our warm-up portion, and we'll start the notes portion of our lesson here. So first thing I'm going to do is take the notes cut out for area formulas. They both actually say that, but this one has rectangles and squares on it. So it's the first one, and I'm going to put it right up in the corner in our usual starting point. We don't always put the first one there, but we most often do. So get it glued down with tiny tadpoles. If you ever want to know what I mean when I say tiny tadpoles, just ask my students. They'll tell you. Tiny little smears of glue, magical Elmer's, that's all you need, and it'll stay forever. All right, so now it's glued up there in that section where I want it to be. With my yellow highlighter, I'll highlight this area formulas so it stands out nice to me on what's being talked about on that little sheet of paper. So then after that, let's talk about what's being talked about on this little sheet of paper. All right, with my pink highlighter, we're talking about the formulas for finding area of a rectangle and of a square. Right? So this first one here that says area equals length times width. I want you to highlight that with your pink highlighter. And then with your pencil out to the side, I'm going to write, this is how we usually write this formula. This is what it should look like. A equals, okay, length times width. Now, when you have two variables right next to each other and there's no operation symbol between them, no multiplying symbol, no division symbol, no add or subtract symbol, if there's no operation symbol between them, that automatically means multiply. So you can write this A equals length times width, and you'll see me do that a lot. Okay? But these both mean the same thing. Now you'll notice I'm using a little cursive lowercase l, and the reason for that is if you just wrote A equals L like that, real soon when we start getting into algebra, that's going to confuse you and make you think, is that a 1 or an L next to a variable? Okay, so train yourself now, if you will. Make that L a little cursive L so you can clearly see that that is a L and intended to be an L and not number 1. All right, so that's our formula. Most of you are probably already familiar with that. We've talked about that many times in your previous lessons, how to find area. Area equals length times width. All right, now, in this curriculum, they also have an area of a square. Finding the area of a square is essentially the same thing as finding the area of a rectangle. It's just that with a square, we know what makes it a square is that all sides are of equal length. So which one is length and which one is width? How would you know which to put first? Well, they're all the same, so it doesn't really matter, right? So usually get my highlighter here, for area of a square, it's going to say area equals side times side. Any one side times any other side is going to get you area because all the sides are the same. And sometimes this is written as area equals S squared, because squared simply means that number multiplied by itself. So side times side is the same thing as S squared. I won't be writing this in this lesson. In fact, I don't even really use this as a formula because I just think of it as length times width. It's side by side. But this curriculum wants you to know that difference. All right? Okay, so let's get on to looking at how we use these formulas. What does this all mean? All right, so over here to the side, I am going to write find the area. And previously we were dealing with perimeter. So let's remember now we're dealing with area. And that is quite different than perimeter. So find the area of the rectangle. They're telling us we're going to be finding the area of a rectangle. Okay, so the area of a rectangle. So I'm going to get my ruler out and create a little rectangle here, and it is going to be 1 3/4 inch. I'm going to make sure I'm looking at my inches side of my ruler and not my metric side. Okay, 1 3/4. And my rectangle probably won't be perfect, but that's okay. We'll measure it and we'll label it and we'll know what it is. And I want it to be 3/4 of an inch wide. So 3/4 of an inch wide. It's hard to keep things perfectly square when you're just freehanding like this. But that's okay. We'll know what we mean. So what did I say? I want the length 1 3/4, right? All right, so that should be there. And I should be able to meet up those two lines now, hopefully. Nice and close. Okay, got it. And then I'm just gonna trace over it with my little purple pencil here. Or dark blue, it doesn't really matter at this point. I just want to give it some emphasis. Okay, what I'm tracing here is the perimeter of this shape. We're not talking about perimeter in this lesson, right? We're not talking about perimeter, okay? I'm gonna go ahead and label that so we remember, okay? That is perimeter. But what we are trying to find is the area of this polygon, this rectangle, and that's everything inside the perimeter. Everything inside the perimeter is the area. The area is what we are going to be looking at here. So for me, I'm going to write area is this. Okay, that's area. All right, we need some labels on this rectangle so we know what is the dimensions. So the length of this is 1 3/4 inch, and the width of it is 3/4 inch. All right, so now we've got our shape all ready for us to work with. And now we can figure out how we use this formula over here to find the area of this rectangle. All right, so whenever we are using a formula, any formula, and you'll hear us repeat this over and over as we move forward, the first step is always to write the formula. Even if you know, and you will very quickly know these formulas by heart, part of us making sure you don't forget them is to make you write them over and over again, truly. All right, so what's our formula for finding the area of a rectangle? It's A equals length times width. All right, so I'm going to write it out nice and big here. A equals, remember my lowercase cursive here, length times width. All right, now the second step is to plug in our known values. We know what the length is and we know what the width is. So I'm going to write 1 right under where I've got my L in the formula, 1 3/4 times, and right under where I have my W in the formula for width, I'm going to write the dimension of the width of our rectangle, which was 3/4. All right. So now I'm just doing some multiplying of a mixed number with a fraction, and I know the first step I have to do in that is to turn that mixed number into an improper fraction. So 4 times 1 is 4, plus 3 is 7. I keep the denominator. Multiplied by, just bring that 3/4 down. My next step would be to do any cross reducing, but 4 and 3, nothing I can do with them. 4 and 7, nothing I can do with them. All right, so I'm just going to have to multiply my numerators across. 7 times 3 is 21. 4 times 4 is 16. Okay. I have an improper fraction there. That can't stand, right? Can't have that. So I've got to turn that into a mixed number. 16 is going to go into 21 just once, leaving me with 5 left over. And I just scooch that denominator right over. Now, I'm not done, because we're dealing in measurements. There's got to be a label here. So I know I'm dealing in inches, and so I'm going to write inches here. But here's the thing we need to remember. When we are dealing with perimeter, we're not multiplying anything. We're just adding up the edges. And so our label would simply be whatever the measurement we're using. But when we are dealing with area, we are multiplying two figures. And that means then that our answer is squared. And we show that with a little 2 there. Now there are 2 different ways you can show that. You could do it like I did it with inches squared like that, or you could do it 1 5/16 inches squared, abbreviated like that, or squared inches. Either way, you can write it all out or abbreviate it in any order. You'll see me do this most often because it's shorter. And the least amount of writing I can do is, actually I probably should just leave that there, huh? Show you inches squared is fine, or squared inches is fine, or the words all written out is also fine. What's important is that we remember this is not a linear, meaning all in a line measurement. This is an area, a measurement of a grid. 2 numbers are getting multiplied, and so 2 numbers are getting multiplied here, and so that means it's squared with a little 2 next to whatever our measurement label is. Okay? All right, so that's finding the area of a rectangle. Let's talk about finding the area of a square. Pretty much the same. Okay? Oh, I will write find the area of the square. All right, so we're looking at area. I'm gonna go back with my red pencil actually and just do a light circle of area. Soon, finding area and perimeter will be mixed up in your lessons or on your tests. So paying special attention to what they're asking you to find, area or perimeter, is going to be very important. Okay, so just like before, I need to get my ruler out and draw myself a square here. See, I'll make it as square as I possibly can. And my square this time is going to be 1 1/4 inches. So 1 1/4. Oh, it's kind of hard to see that right on the line, isn't it? 1 1/4. And right again here, 1 1/4. One 1/4. That's a square, so all its sides are going to be the same measurement. That's what makes it a square. And 1 1/4. And my square appears to be fairly square. All right, so I'm going to outline it here with my purple colored pencil, or maybe that's dark blue, I can't quite tell. But we'll get it well emphasized here so it's easier for you to see. All right, so I'm outlining the perimeter. But perimeter is not what we are measuring. All right, so now what we are measuring is the area. That's the grid area within the perimeter. So on any polygon, any closed multi-sided shape, the part within the perimeter, inside the perimeter, is area. And that's what we're measuring. Well, on my square here, it has a side of 1 1/4 inch. Okay, 1 1/4 inch. I only need to label one side because I'm telling you right here that it's a square. And if it's a square, then all of its sides are going to be the same. All right, so first step is to always write down the formula. So the formula for a square is A equals side times side. You could have written that as side squared like we did up here, but we haven't really talked much about what that means, so you'll get more of that later when we use our formulas in algebra. So anyway, we'll write it as area equals side times side. All right, so now the next step is to plug in my known values. Well, I know one side is 1 1/4. If it's a square, that means all sides are 1 1/4. So that's what I'm multiplying. All right, next step is to turn those mixed numbers into improper fractions. So 4 times 1 is 4, plus 1 is 5, over 4. They're both the same, so I better write down 5 over 4 again. Now I check to see if I can cross-reduce. 4 and 5 cannot be cross-reduced. 4 and 5 cannot be cross-reduced. So I'm going to have to just multiply straight across. My numerators, 5 times 5 equals 25. My denominators, 4 times 4 equals 16. Okay, equals, all right? I've got a 16 can go into 25 one time with, did I make a mistake here somewhere? 4, 1, 4, 5 over 4. Oh, no, I'm good. Okay. Sometimes I just have to double check. All right, so 25 minus 16 is going to be, let's see, 9 over 16. Okay. Can 9/16 be reduced? Well, I'd look at this and see, can 9 go into 16? No. I know a factor of 9 is 3. Can that go into 16? No, it can't. So 1 9/16 is reduced. I'm dealing with inches here, and I'm dealing with area, so it's inches squared. Inches squared. All right, so that's my final answer there. 1 9/16 inches square is the area of this square. Okay, all right, so Finding area of rectangles and squares is on the first page. Now, I told you this was going to be a 2-pager, so let's set this one aside and get ready for the second page, which in my class means that this is page 51. Should be labeled there. And I'm going to be putting the next notes cut out, which is area of triangles, right up here in this location. Okay, so get my glue. Come on, glue. All right. Okay, give it a press. And yellow highlighter, what is this talking about? It's more area formulas. This time we're talking about triangles. Triangles are a little different than dealing with rectangles and squares. So the formula for the area of a triangle is 1/2 times base times height, right? And so we show that, this is how you'll see it, is area equals 1/2 base height. Remember, anytime I have variables right up against each other with no operations showing in between them, it automatically means times. So I could show it, and I will when I'm showing it on my paper, 1/2 times base times height, right? Now, this is all being multiplied, the 1/2 and the base and the height. So does it matter what order I put those numbers in? No, we know in multiplication order doesn't matter. Okay? But we'll work with it in that order because that's just what they decided the order should be for this formula. I'm sure there are very mathematical reasons, but this is how we'll memorize it. So when I ask you what is the formula for the area of a triangle, for finding the area of a triangle, you should be able to say area equals 1/2 times base times height. All right? Okay, so we'll come back to talking about what's at the bottom here later. Okay, but right now I just want to talk about how we find the height of a triangle. Okay, so I'm going to take my pencil here and I'm going to draw kind of a random triangle here that's not too terribly perfect. It's going to go like, oh, I need some more lead. Here we go. It's going to go like this and way out like that and across. Okay, so I'll get my blue pencil, I think it's the blue one, and just give the perimeter some emphasis. And we'll talk about the parts of a triangle as it relates to this formula. All right, so with my red pencil, I'm going to write right here, not, then I'll go back to the blue, the height, H-E-I-G-H-T, and draw a line, an arrow rather, to this part here. Okay, the height of this triangle is not, this is the base, we'll get there in a minute. The height is not this measurement. Okay, the height of a triangle is from the base to its opposite vertex. That means corner. Okay, so the height is from here to here, the opposite corner, not along here. That is not your measurement of height. Sometimes it can be if you have a right angle in there, and you'll see what I mean, because the two lines are perpendicular. That means at 90 degrees from each other. We'll talk about that a little later too. So here's how we would show the height then. With a little dotted line from the base to the vertex, its opposite vertex or corner, we show that dotted line, and this little square means that this dotted line, this imaginary line here, and this base line here, they are perpendicular to each other, therefore forming a right angle right in here. Okay, that's what that means. All right, so I'm going to take my purple pencil and write under here, or blue I guess it is, base. Okay, this is the base of our triangle. And then with my red pencil, I'm going to write in capital letters, this is the height, H-E-I-G-H-T, and make a little arrow to our little, you have to make that sound, you know, to our dotted line inside the triangle there. That's our height. Not the height on this triangle, is the height. All right, so it's important you know how to read that, because soon they'll be giving you shapes that ask you to find the perimeter and the area, and you need to be sure you're using the correct measurements for each. All right, so I did a lot of explaining here. We better put it in the notes for your future use. With my light green pencil, I'm going to write the height is measured from the base of the triangle The height is measured from the base of the triangle to its opposite vertex. Vertex means the corner. Okay, keep it simple here. All right, okay, so that's how it's done. The height is measured from the base to its opposite vertex. All right, so now let's go back to talking about what we see here. We talked about it just briefly right there, but let's get it into our notes. With my dark blue pencil, I'm gonna write, let's imagine we were asking this question. Hey, what are all those little squares? What are all those little squares? Okay, so you'll have to pardon the splice that came in here. My battery went out and I was unaware for a short while. So we were talking about, hey, what are these little squares? And even though we talked about them up over here, I wanted to put them into the notes so that we don't forget what they mean. So to answer the question, what are all these little squares? Well, they mark a right angle where two perpendicular lines meet. And that's how we also determine the height of a triangle using that. All right, so then up here, I just wanted you to go ahead and make an orange mark to section off that part, and we'll show how we use this formula to find the area of a triangle. So with my black pencil, I wrote over here, find the area of the triangle. And again, just so I'm remembering, what is it I'm trying to find? Area, not perpendicular at this point. All right, so let me move up here and show you how I drew a triangle over here, and it has a height of 1 1/2 inches and a base of 1 1/4 inches, and we are going to try and find the area of that triangle. Just disregard this for right now, it'll make sense in a little bit. So I will write down A for area equals 1/2 times base times height. I'm just leaving a little room here so that when I plug in my values underneath, they kind of line up. All right, so next step is to plug in our known values for our triangle here. All right, so 1/2 doesn't change. times base. My base is 1 and 1/4, 1 and 1/4, times my height is 1 and 1/2. Okay. Now I know that I cannot multiply those as mixed numbers, so I have to copy these down here on the next line as improper fractions. So 4 times 1 is 4, plus 1 is 5 over 4. 2 times 1 is 2, plus 1 is 3 over 2. Now I'm going to look at all three of these fractions and see, is there any cross reducing I can do? 2 or 5, 2 or 3, nope. 1, 4, that's 4 and 3, nope. 2 and 5, 2 and 1, nope. It's all as simplified as it can get. So I'm going to multiply straight across. My numerators, 1 times 5 is 5, 5 times 3 is 15. My denominators, 2 times 4 is 8, 8 times 2 is 16. So I have 15 sixteenths. But these are measurements. I need labels. I'm dealing in inches here, so it's going to be inches, and I'm finding the area, so that's base and height being multiplied, so the area is squared. Area is always squared. All right, so my answer for the area of this particular triangle is 15 sixteenths inches squared. All right, okay, so one thing that can make finding the area of a triangle easier is this. Let's write out a little reminder note to ourselves, okay? Remember. Okay. Oops, I totally misspelled that, didn't I? I think I forgot an entire syllable, and this does not erase very well, so you'll just have to work with me on that. Okay. Remember, here we go. Remember. All right. 1/2 times a number is the same as thinking what is half of the number? Okay, and here's what I mean. So here's how you apply this when you're working. Okay, so if your formula, and I'm still talking about the formula for finding area of a triangle, if your formula winds up looking like, well, let's say something like, because it could be all kinds of things, something like 1/2 times 5 times 2. Let's say you had a triangle that gave you numbers like that. Well, then what you want to do, instead of setting it all up as a bunch of fractions, is multiply the two whole numbers which in this case would be 10, and then think 1/2 of 10, which is easy, right? 5. Okay, that's quicker than putting the 5 above a 1, putting the 2 above a 1, multiplying across, and finding your answer. I mean, you're going to still get the answer, but if you've got easy whole numbers that can be divided in half, then this is a quicker way to do it, and you'll see that more later. So with my brown pencil, I'm just going to, why did I even say all of this to myself? Well, later when I look at this, I want to remind myself that it might be quicker than multiplying I'm going to abbreviate, fractions. Gotta write small. Might be quicker than multiplying fractions. That's why I want to do this. Okay? All right, so that's the end of our notes portion. Let's take a look at practice problems. Okay? So, practice problems for lesson 6.1. I'll show you the top part of the page and pause for a second. And the bottom part of the page. And pause for a second. Okay, so let's see how we work these. It says, use the given measurements to find the area of each polygon. Polygon, as we'll remember, is any shape that has 3 or more sides that create a closed figure. All right, so all of these shapes are polygons. All right, well, we have a rectangle here that has a length of 7/8 and a width of 5/8. You know, it's often we're looking at them and your length is here at the bottom and your width is this way. How do you know which one's the length, which one's the width? Well, again, remember, we're multiplying, so order doesn't matter. If you're not sure, it doesn't matter. But generally, the longer side is considered the length and the shorter side is considered the width, no matter which way it's turned on your paper. All right, so I know that the first step in finding the area is going to be writing the formula. So that is A equals A for area, length times width. All right. My length on this one is 7/8. My width on this one is 5/8. My next step is to see if I can cross reduce 7 and 8. Nothing I can do there. 5 and 8. Nothing I can do there. All right, so I'm going to 7 times 5 is 35 over 8 times 8 is 64. Big numbers there. Let's see, a 35 and a 64. What are the chances that I can reduce those? None. That's as small as it's going to get. Well, what were the measurements I'm dealing with? On this one, it's inches. So I'm going to write inches. And remember that I'm dealing with area, so it's squared. So the answer to number 1 is 35/64 of an inch squared is the area of that rectangle. All right? Okay, so number 2. Number 2 has a rectangle also, and it has a length of 1 3/8 inches and a width of 1/4 of an inch, 1/4 of an inch. So again, my first step is to set up the formula. Area equals length times width. My length, now I got to plug in the values, is 1 3/8. And my width, plug in the value, is 1/4. Okay, I can't have this mixed number there when I'm multiplying, so I got to turn it into an improper fraction. 8 times 1 is 8, plus 3 is 11/8 times 1/4. Okay, cross reduce 8 and 1. My 1 here tells me that's as simplified as it can get. Cross reduce 11 and 4. Nope, there's nothing I can divide evenly into both those numbers. So I'm going to have to multiply my numerators. 11 times 1 is 11. 8 times 4 is 32. Can 11/32 be reduced? No, it can't. So I'm going to label it with my inches. I'm dealing with area, so I'll remember that it's squared. 11/32 inches squared is my answer for number 2. All right. All right, now down here to this triangle. Okay. I've got a base here on my triangle of 2 1/4 inch, and my height. And I remembered here that my height is not this line here. My height is whatever is the opposite from base The opposite from base is this here, and it has to be at a right angle, perpendicular for my height. So I have to make this little dotted line that goes out to the side to get a right angle up to my height. And it's labeled as 1 1/8 inch is the height of this. So where do I start? I start by writing the formula. Formula for triangle is A equals 1/2 times base times height. All right, so now I have to plug in my values, bring down that 1/2. Base is 2 1/4. Height is 1 1/8. Now to multiply these fractions, I have to turn my mixed numbers into improper fractions. So that means 4 times 2 is 8, plus 1 is 9. Whoops. Hang on while I get some more lead. Here we go. 9 over 4, you keep the denominator. 8 times 1 is 1, plus 1 is 9 over 8. Now I'm going to look across all these fractions and see if there's anything I can cross reduce. I got a 9 and a 2 and a 9, no. I got a 2 and a 9, no, I can't. 9 and 8, nope, nope, nope. 4 and 9, nope, there's nothing I can cross reduce. Dang it. All right, well, 1 times 9 is 9, 9 times 9 is 81. Okay, now multiply the denominators across. 2 times 4 is 8. 8 times 8 is 64. And now that's an improper fraction. I need to turn back into a mixed number. 64 can go into 81 only one time. And 81 minus 64, that leaves me a remainder of 17. And I scooch that denominator right on over. We keep it. All right, so this one was also inches, and I'm being asked to find the area, so it's going to be squared. So that means the area of this triangle is 1 17/64 inches squared. All right? Okay, last one. We have a word problem here. There are 2 rectangles, and each have an area of 12 inches squared. Find the dimensions of the 2 different rectangles that fit this description. Now, there are a few possible answers, but what they're really trying to get you to think about is, well, if the area is 12 inches, how do you find area? What's the formula for area? The formula for area is length times width. So what are the lengths and the widths that, if you multiplied them, would give you an area of 12 inches? Okay, so they're really just asking you, what are the factors of 12? You know, what numbers can multiply to give you a product of 12? So it said to write down the dimensions, find the dimensions of 2 different rectangles. So you may have something different, but I had 6 inches by 2 inches. If I had a length of 6 inches and a width of 2 inches and I multiplied them, I'd get 12. That my area would be 12. So that does answer the question. The other one I got was 4 inches. If I had a length of 4 inches and a width of 3 inches, that also would give me an area of 12. We know 1 and 12 are factors of 12. So you could have also had there a length of 12 inches and a width of 1 inch, and you would still have an area of 12 inches. Okay, so that's the practice problems for lesson 6.1. Let's have a peek at the 6.1 worksheet. 6.1 worksheet. There's nothing really tricky here. That's all the kind of same stuff that we've done in our lesson. I would say pay attention to, well, all of these are talking about, in these shapes here, they're all using the measurement of inches, so that's good. But remember, when you write your answer on this line here, don't forget that those are inches squared. Your problem will be wrong if you just say like 3/4 inch. It must be 3/4 inches squared in whatever format you wish to write that. So down here, I think we're dealing with, oh, this one's a rectangle, this one's a triangle. Sketch it out. Don't forget to write your formula and work it out. Down here, they're going to ask you to measure these shapes and then do what you did at the top of the page where you've got to find the area. But first you have to get your own measurements, and they're not giving them to you. When it says to the nearest 1/4 inch using a customary ruler, don't worry, they all measure out to the nearest 1/4 of an inch, which means the measurements will all be either a whole number or a whole number plus a 1/4, 1/2, 3/4, or to the next inch. But just measure exact and you'll get to the nearest 1/4 inch. There's no rounding they're expecting you to do, so don't worry about that. Okay, so that's the worksheet. Last part then for this lesson would be your exit ticket. Exit ticket. I don't give you the answers to the exit ticket. I simply put this up here in case you'd like to double check that you understand this lesson, and your teacher may use it at another point in your lesson as well. Okay, so that's lesson 6.1. Remember, the only way to learn math is to do math, and mistakes are proof that you're learning.